guys? Oh, admit it, you missed the music. Welcome to another fun edition of Patio Productions. So welcome back from spring break. I hope you were successful in completing the group quiz for chapter 13. This video is so that you can correct your work. And then when you are done with your work, you're going to fill out a sort of like a Google form that just tells me how you did and what you need to work on and what you completely had nailed, and then tell me who you work with. So just as a reminder, we are taking a test. This is why we did the quiz, right? We're taking a test on chapter 13 coming up Friday, which is 2021, 22, 23, 24, on the 24th. So on Friday the 24th, you will be taking that exam. And on Wednesday, we'll be putting out a video that goes over more details about specifically on how to do that test, since this is our first test, right? I know, so fun. Okay, so let's get to it. Let's correct our quiz here. Again, when we are correcting this quiz, I am going to try to do a little bit of explanation. I'm not going to work out the entire thing. That's what would be what office hours are for. But this will be definitely good for us to just practice. You can pause the video at any time that you need to and do everything, whatever you guys need. And yeah, let's do this. Here we go. Okay, so this is our chapter 13 group quiz. I'm going to get my little pencil ready to rock here in case I need to write anything down, but let's do this, okay? So the answer to number one, the way to do number one is that it says find the first 5 terms of this sequence. And so what they've given you is an explicit formula. And I know it's explicit because it's just I can plug in n and find any of the terms. And so that's what I went ahead and did. If you can see kind of like my work, I have listed n equals 1, 2, 3, 4, and 5, and I just sort of plugged each of those in to the formula and got the right answer, taking the -1 to that power and then multiplying that number also n by 5. My list of the first 5 terms is -5, 10, -15, 20, and then -25. For number 2, it asks us to find an explicit formula, okay? And so when we find an explicit formula, we sometimes need to see like what the pattern is. And when I looked at this pattern of -7, -3, 1, 5, and 9, I recognized that was in fact an arithmetic sequence. Arithmetic sequences have like a rule that you can just go ahead and plug some numbers in. You end up taking the first term, a sub 1, and then adding in parentheses n-1 times the common difference. So my common difference happened to be 4. It's going up by a +4 each time, and my first term was a -7. So that is literally what I wrote down for the first answer right here. A sub n equals, you do need the a sub n part, -7 plus n-1 times 4. I might have even put the 4 in parentheses. That's especially important if you're doing like a negative number for the common difference. This would have been a beautiful answer, but if you decided to distribute the 4 and simplify, I also would have accepted an answer of a sub n equals -11 plus 4n. Either of those answers would have been correct. Okay, now question number 3, it says find the next 4 terms of the sequence, and it's a recursive formula, okay? Now, how does a recursive formula look different? They end up giving you the first term, and then they say what to do to that previous term to get the next term. And then they always have this like for n greater than 1. So basically it says that we're going to take 2 times the previous term. That is how in my brain I read a sub n-1. Yeah, the notation doesn't really mean anything, but when I say it in English, that feels really good. So 2 times the previous term and then -5. So that's basically just what I kept doing. So the first term was a 3, so I did 2 times 3, which is the previous term, and then subtracted 5 and got 1. Then I went 2 times 1, which was the previous term, and subtracted 5 and got 3, etc., etc. The answers are 1, -3, -11, and then -27. For example, number 4, it says that we are reporting our own recursive formula. Now, I really feel like that a mistake that people make is not putting this like for n greater than 1 on there and not like doing the appropriate labels. So really, 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 really look at this answer, guys, like for sure. Okay, so it says the sequence goes 1/2, 1/4, 1/8, 1/16. If you look at it, it looks like you are multiplying by a negative, not a negative, seriously. Spring break brain, can't think right now. I'm multiplying by a 1/2 each time. So I'm going to say a sub 1 is 1/2. And then what am I doing to each term? So a sub n is a sub n minus 1. Remember, this is the previous term times 1/2. And then starting with n greater than 1, starting with the second term, that is how I would get that guy right there. I know it looks nice, right? But make sure you have all three parts of this answer, right? You have to have the first term, you have to have what you're doing to the previous term, and then where you're starting with it. So there are three parts to this. Okay, question number 5, it says find an explicit formula for this arithmetic sequence. They gave me the 5th term and the 8th term. So I had some work to do. This might have been kind of like a tricky question for you guys. Like, I don't know, but like this one was, yeah, it's a little difficult. So if you missed number 5, don't feel bad about it. Just kind of like learn from it right now. So what I decided to do is just to use, it says it was an arithmetic sequence. So I was like, okay, I'm going to use the arithmetic rule for each term of a sequence and then build from there. And then I basically made like a system of equations. So I said the 5th term would be the first term plus 5 minus 1 times the common difference. I don't know the first term or the common difference, but that's okay. Then I said the 8th term would be the first term plus 8 minus 1 times the common difference. I did a little combo. The 5th term was 10, and so I got 10 equals 4d plus a sub 1. And then the 8th term was -2, so then I got -2 equals 7d plus a sub 1. I went ahead and ran a negative through the second equation. The a sub 1's canceled. I got an 8 was equal to a -3d, which made my common difference very inconveniently. So if you got a weird number and you were nervous about it, you were actually right. Okay, a -8/3 for the common difference. And then I plugged that back into one of the equations and got that the first term was 62/3. Now, none of this was really freaking me out because I had my my scientific calculator. So I just kind of put everything in with the ABC key and it was fine. And so there's actually 2 different ways that you can report the explicit formula. One of the ways is just to leave it as the formula. Go a sub n is 62/3 plus n minus 1 times the 8/3. You can see how I did my parentheses right there. Or you can go ahead and distribute the 8/3 and combine like terms. That other answer is 70/3 minus 8/3 n. Either one of those is fine, right? 2 different choices. But then the second part of the question says find the 12th term of the sequence. And so basically all I did, I think I did it in my calculator because I don't even have any work shown here. I just plugged in 12 for the n spot, and then I got either one of these answers, either -26/3 or -8 2/3. Probably my favorite answer would just have been the -26/3. I'm not a big fan of mixed numbers, but it's still okay. All right. Okay, the next 2 questions, we're trying to decide if the sequence was arithmetic, geometric, or neither, and then if it was, to find the details about it. So when I looked at this question number 6 right here, it went 8, -4, 2, -1, 1/2. It did look like we were multiplying by something, the same thing each time. And so, sorry, someone's having a little motorcycle fun on my street. It looks like we were multiplying by a -1/2 each time. So then I said, oh, if you're multiplying by something, or that would be geometric. And then what am I multiplying by? A -1/2. If you thought in your head that you were dividing by a -2, that is the correct thinking, but you have to report it in a multiplication format. So that's why it's multiplying by -1/2. When I went over here to number 7, it was probably really easy for you guys. It went -10, -6, -2, 2. It looks like we're just adding 4 each time, which does officially make it arithmetic, and that common difference is a +4. Okay, we went on to number 8, and it said find the 3 arithmetic means between 64 and 82. If you remember, there was sort of like a short, streamlined way to do this. You wrote the first term and you wrote the last term, and then you put commas and spaces for all those 3 arithmetic means. So I went 64, comma, space, comma, space, comma, space, comma, 82. You end up doing in the streamlined formula 82 take away 64, the last guy minus the first guy, and then divide by the number of changes or the number of commas, right? So change, 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 or count the commas, doesn't matter. 82 minus 64, all divided by 4, happens to be 4.5. That is my common difference. So then I went ahead and added 4.5 to each of the terms and found the 3 guys in the middle. These numbers are what would be inside and written on these blanks. You could have written it as a fraction or as a decimal. Doesn't matter to me, but the answers are 68.5, 73, and 77.5. Moving on to number 9, this one says find the mean proportional between -8 and -14. Guys, this is when you do the geometric mean. And what happens is the first thing you have to decide, woo, excuse me, I had a little sneeze there. The first thing you have to make sure, guys, is that the signs are the same. If the signs are not the same, then you do not get to find the that mean proportional, that single geometric mean, but they are, so that's fine. And then I think I'm going to add this detail. I think in the notes when I was first going over it, I said that the answer was supposed to be plus or minus. So if you put plus or minus, you did exactly what I told you to do. I think I was mistaken, though. What you really should do is make it be the same sign that the original 2 guys were. So if these 2 are negatives, okay, on the original, then I want this to be a negative also. So the way that you're supposed to do it is you multiply the 2 numbers together and then take the square root of that, and then we'll just make the answer negative to match. So 8 and 14 is 112. It can be simplified to be 16 times 7, so a 4 rad 7, or you could just put it in your calculator and do 10.6. I'm thinking on the exam we do simplified radical notation, so make sure that you can at least do that yourself, okay? All right, moving on to number 10. I know sigma notation is sometimes a little tricky for us, right? But really with sigma notation, if you remember, all you're doing is you write the sigma. We usually use k equals 1 to infinity, especially if it has like this dot, dot, dot over here. And then right here, guys, you're just putting the rule. That's all you're doing, okay? Whatever the rule is. When I look at this sequence, the sequence of number of a 0.2, a -0.8, a 3.2, a -12.8, it does in fact look geometric, okay? Now, because it was geometric, I just went with the geometric rule right here, okay? It's the first term, right? This right here is the first term, and then this is your common ratio, and then to the k minus 1 power. So the first term was a 0.2. Looks like I'm multiplying by -4, and so I put all that together. Probably what you would have put down, I'm guessing the most common answer is this first version right here. The k equals 1 to infinity of 0.2 times -4 to the k minus 1. However, if you decided to start your k at 0, that is actually perfectly acceptable. Yeah, you just have to make it be to the k power instead of the k minus 1 power. So either answer would have been correct. Okay, number 11. So on number 11, we're just finding the 9th partial sum of this lovely guy. Now, there's actually 2 different ways to do it. Because you're only finding S sub 9, what that means is that you actually could have written out the first 9 terms, right? And then added them together. I thought that that was a little inefficient, right? Like, I'm not really like a fan of that. Yeah, so I decided instead I would just use, I noticed that this would be an arithmetic sequence. So I just went with for the arithmetic sum, and it's the number of terms divided by 2, and then the first term plus the last term. So to get the first term, I plugged in 1, which I got 2.2. For the 9th term, the last term, I plugged in 9 and got 43.8. I added those 2 together and then did 9 over 2 for the 9 terms, and the answer is 207. Question number 12, okay? We were doing the binomial expansion theorem. This one is a little bit busy. It's got a lot going on. So because it was only to the 5th power, I went ahead and just did the Pascal's triangle up to 5 because I thought that that would be easy enough for me. So you can kind of see that at my work on the side here. So the 1, 5, 10, 10, 5, and 1 are my coefficients. And you can see that I just started by writing the coefficients. So 1, 5, 10, 10, 5, and 1. And then I just did the first guy, which was a 3a, and I did those starting with the power of 5 and went down. And then I had a negative 2b to the -1, and that went powers going up. Okay, once I wrote down all of those things, I went ahead and simplified each of the terms, right? So the -2b to the -1 to the 0 power went away, and that was just a 3 to the 5th. Can't forget to do that, which was 243, a to the 5th. Then over here, I ended up doing a 5, and then times a 3 to the 4th, and then a -2 to the 1st. Multiply that all together, and you're golden. So the answer is this loveliness here. So I'll try to I'll rattle it off. It's 243 a to the 5th minus 810 a to the 4th b to the -1 plus 1080 a to the 3rd b to the -2 minus 720 a squared b to the -3rd plus 240 a b to the -4th minus 32b to the -5th. Just a side note, if you were writing your b's on the bottom of a fraction, right? Like just for instance, this term right here, if you wrote this as negative and then you did 810 and then you did your a to the 4th up here and then you made a style choice of putting this over a b power, that is also perfectly fine. So if you have yours written a little bit differently than mine, it's still good. You still got it right. Nice work, nice work. It's totally fine. Okay, moving along to number 13. One of the fun things that we like to do is just ask you not to expand the entire thing, but just ask you to find one of the terms. So I asked you to find the 9th term for this expression of x minus 3y to the 14th. So probably what I did is I kind of like did it in pieces. I probably wrote down to myself that I'm going to take an x to a power and then a -3y to a power. So I'm guessing that I kind of left these blank first. And then probably what I did is I just started counting. So I kind of held up 9 fingers. And then I knew that the first term, the x's, would start with the 14th power. And then I just sort of counted down. So I basically went 14, 13, 12, 11, 10, 9, 8, 7, 6. So I knew that the x guy was going to be to the 6th power, and then everything just kind of like flowed from there. So I did the x to the 6th power. I knew that the -3y would be to the 8th power because those two have to add to 14. The coefficient in the front, we know that it's just going to be the 14 factorial and then over the 6 and the 8, each of those factorial. Now, when I put this in my calculator, I had to be very careful. I had to make sure that I put this in parentheses on the bottom. So if you happen to not get the right coefficient out here, that's probably what you did. You forgot to put the bottom in parentheses. And then I raised each guy to the power. I also had to take a -3 to the 8th power, which is this 6561 right here. And then I multiplied that all together. It's 19,702,683 x to the 6th, y to the 8th. We did it. Nice work. Okay, number 14 and number 15 are now giving us, like, people have a hard time with these. I know, I don't know why, but I think it's just because it's very new. We're just determining if the sequence converges or not. And I think what makes these hard is there's not like one way to do it. You kind of have to have this breadth of knowledge to sort of like work up to. One of the strategies that you do if you're deciding if something converges or diverges is that what you do is you go ahead and you try to like simplify. So I decided to sort of divide the top and the bottom both by an n. And then I had 3 over 2 minus 1 over n. And then what I actually did, and it's not shown on my paper, but I took the limit as n approaches infinity. And when I did n approaches infinity, this 1 over n power went away, and all I was left with was a 3/2. So it is a 3/2, and it does converge. Now, this guy over here for number 15, this is actually just a geometric sequence, okay? It is a 1/4 to the j power, and I guess like there's a 1 in the front. So whenever the r, the common ratio, is less than 1, it will totally converge. And if you think about this one, how did I know what it converged to? So this one definitely converges because 1/4 is in fact less than a 1, and that would be, of course, the absolute value. But 1/4 is less than 1, totally. But then how did I know that it converged to 0? Well, maybe on this one, I would have written out some of the terms. So like the first term would have been a 1/4, and then the next term would have been a 1/16 because I would be squaring it, and then it would have been a 1/64. And so if you kind of look at the pattern, folks, it looks like that these numbers on the bottom are just getting super large, and it's just a 1 on the top. And so again, 1 divided by a really big number basically just goes to 0, and that's how I knew that number 15 converged to 0. Okay. Number 16. Okay, it says determine whether this series converges or diverges. Kind of the same thing, kind of like a revisit of this number 15 question. This is, in fact, geometric. Okay, we are taking a 1/3 and multiplying it by the 1/3. So it is for sure geometric. What does the series converge to, right? So this is the series. This is not a sequence this time. It's a series. So there was a formula for the sum of a geometric series. It was the first term over 1 minus the common ratio. If I plug in 1 right here, okay, my first term is a 1/9 because you end up having a 1/3 to the second power. So the first term is a 1/9. And then that is my R right here. This is my R. So my R is 1/3. So that's what I put over here. 1/9 divided by 1 minus a 1/3. And so I'm golden. So yes, it converges. It converges to 1/6 because I went ahead and put this in my calculator and simplified that up to be 1/6. And then it said, why did it converge or diverge? Well, it does converge because the common ratio is less than 1. The absolute value of that 1/3 was less than 1. It is possible that you missed a teeny part of that number 16. There was a lot of little pieces to that, and if that's okay, that's cool. But now you know for the future. Okay, number 17 is classic. Classic word problem about the ball going down and bouncing and all that good jazz. And so it says this ball is dropped from a height of 40 feet. Each time it strikes the ground, it rebounds to 70% of the distance that it fell. Probably what I don't have on this is a picture. And so what it basically looks like, it has a down and then it goes up and down and then it goes a little bit less and a little bit less, etc. So this original 40 right here, this is the original 40. I'm going to not count that, and I'm just going to count all the rest of this stuff in my sequence, right? Because it just keeps on going. And so on this guy, it goes up 40 times 0.7, down 40 times 0.7. And then this goes up 40 times 0.7 times 0.7, down 40 times 0.7 times 0.7. And so this is the sequence all written out. It's the original 40 and then plus the series now. And so this part right here, all of this part ended up being a geometric sum. And so this was the first term, which is actually a 2 times a 40 times a 0.7. That's the first term. And then I'm multiplying by a 0.7 each time. And then I have the original 40 to deal with. And so I put all of that in my calculator and I got 226.67 feet. Very nice. Okay, question number 18. Okay, this one says find a power series that converges to this guy right here. We are looking for something, it's just kind of popular in these last couple of questions, where S is equal to the first term, right? It's just popular again. S for a geometric series is equal to the first term over 1 minus R. What is super key, guys, is getting a 1 in this spot. This guy right here did not have a 1. So I had to factor out a 3 to make it be a 1. So the bottom became a 3 times a 1 minus 2/3 x. And then I went ahead and just made this the entire numerator. So then this 1 was isolated on the bottom. So it became a 10/3 and then 1 minus 2/3 x. And now everything's in its right spots. Okay. The first term was a 10/3. The R is now 2/3 x, and that's what I go ahead and write with my sigma notation. So it's sigma of k equals 0 to infinity. This is your first term, right? And then you do the R value, 2/3 x, and then to the k power. It looks really nice. Okay, another version of this is to make it be k equals 1, and then do the power as k minus 1. Either of those would have been okay. And then our last question was mathematical induction, right? Yay, so fun. I probably, when I graded the quiz, would have given this 4 points, just kind of like 1 for kind of like the beginning stuff, and then another point for like all of this good jazz right here. And then, of course, you have to have all the English stuff too. So if it doesn't have all of this, it's incomplete, you guys, okay? So the first thing you write in English, prove P sub 1 is true for n equals 1. You take the first term, which is that guy right there, and then you plug in 1 on the other side. So 1 is, in fact, 1 squared. Step 2 would be to assume P sub k is true for n equals k. You literally copy down the entire thing, but just write k's instead of n. So you just write the whole thing. Prove that piece of k is true for n equals k plus 1. Technically, I'm supposed to write this guy first. Then I add the next term that was on the left-hand side, which was a 2 times k plus 1 minus 1. I add that same term to the right-hand side, and then I try to get what I want. What's not on my paper is like my want bubble. Okay, now what I would have wanted comes from this guy right here. I would have wanted it to say a k plus 1. That's really sloppy. Sorry, guys. To the second power. That would have been what my want bubble was. And so I went ahead and distributed, combined like terms, and then wouldn't you know it, k squared plus 2k plus 1 does in fact factor into be k plus 1 quantity squared. You would put your English conclusion of by mathematical induction, the above statement is true for all natural numbers QED. Just like that. Okay, guys, so to get credit for today's assignment, so yesterday's assignment, to get credit for it, you just had to take the quiz and take a snapshot of it and upload it, okay? Today, what you're going to get credit for your homework is filling out the Google Classroom form. You're going to, it's just like we did last time with the previous quiz for chapter 15. You're going to tell me your name, all that good jazz. You're going to tell me what your score was. Guys, I just want to know what it was. You're going to tell me if you worked with somebody, and then you're going to tell me some things that you definitely knew, and then some things that you need to like brush up on and practice before we go into our test on Friday. Okay, guys, so that is it. Okay. That is all there is for this quiz. So hopefully I was able to do enough explanation as we were checking it, so that feels good and you guys are golden. If you still have questions, of course you can come visit me during office hours, because it's really important that you have these concepts down so we're ready for our test. Okay, I think that's it, you guys. So I will see you when I see you next with the details about the test. So exciting, so great. And that will be coming up probably on Wednesday. Look for that on Wednesday. I think that'll be good. All right. I will see you guys. Have a wonderful day. Welcome back from spring break. I think that's it. Bye. See ya.